All right. Welcome to COMP123 in the summer 2017 semester here at Centennial, and we are week 8, part 1 of our broadcast. We are live on YouTube, right? So I wanted to kind of tell you that I'm going to be recording all my classes. This is where it's happening. I have my own YouTube channel. For those people who don't know who I am, it's here. I'm going to publish the link to the YouTube channel here. You can see that there's a live broadcast that's going on right now. What does this mean, live? Does that mean that you should stay home and not come to class ever? No, it does not mean that. It means that you can use this as additional materials because all of my lectures are going to be recorded online, and I have previous lectures recorded in a bunch of playlists. So if you actually go to the playlists that I have and you search for COMP123, you can see that there are a number of different videos that I have from previous lessons or previous sessions. Some of them may apply to you, some of them may not, because the syllabus and the outline has changed over the years, right? Like the last time I did this was summer of 2016, so it's going to be slightly different than what you see here, although a lot of it's going to be the same. All right, so that's one thing I use. The other thing I use a lot is GitHub, which I'll be talking about in a second, but let's skip to what we're doing today, which is, hey, this is me. I'm Tom, right? I'm your new professor for the second half of semester, right? I kind of said hi to you last week, right? And then took off, and now I'm back, and it's me. And there's no more Narendra, right? He's gone on vacation. You might see him around, but for the most part, it's me for the rest of the time. Who am I? I've been doing this teaching thing since 2011, right? I work at Centennial College, mostly in software engineering and interactive gaming, as well as I publish all my lectures on YouTube, right? So everything's up on YouTube. I also put up all my code on GitHub, which we'll be talking about today, okay? So that's me, and we're recording live as I speak, right? So that's one of the things that I'm doing. Now, when I record live, just a bit of a disclaimer for those people who've never been in my classes before. I'm not going to be recording you, so there's no camera focused on your face. You know, I'm not going to be recording you or broadcasting you. However, if you do speak up in class and you ask a question, you know, the internet might hear you, right? Because I got a mic right here that's pointing in my direction. It's not omnidirectional, but it's powerful enough so it can hear what I'm saying, and it might hear you too. So just be warned. I'm not saying to discourage you from asking questions. I like questions, but just be warned that I'm not trying to record you. I'm recording me, but if you ask a question, you might be up on YouTube. All right. I want to review a little bit about classes. So when we talk about classes, people have done this before, and you may have heard some stuff around classes before. I'm going to give you the classic analogy around classes. For me, classes are blueprints or prototypes, right? And I'm telling you about this because I'm a visual person. And typically what I do is when I discuss a topic, I like to create some kind of visuals around it. So this is my visual. My visual is the PowerPoint that you can see. It's up on eCentennial, by the way, and everything that I share with you from now on will be on eCentennial. I do things a lot different than Narendra. I don't have any paper assignments, so there will be no paper assignments. I will not be giving you paper labs. I'm not going to be marking your labs in class like he did. Everything will be up on eCentennial. Right? I'll be using eCentennial for everything, right? Going forward. The labs that he's posted going forward, the way they are in their current form, will not be the labs that you're going to be doing going forward. So all the other labs that he's posted in his P drive, H drive, I'm not going to be using that drive, so please don't look there anymore. I might post something similar to what he has, but it'll be in the way I write my labs, which is slightly different than his. Now, he's got some really great work he's done with you guys up until now, but I'm going to be producing different documents for that. All the stuff that you're going to be doing, all my assignments and labs are all going to be done up on eCentennial. There'll be drop boxes for eCentennial where you will submit your stuff there. I don't want to see any paper coming from you. Please don't email me your stuff. It's not going to happen. I'm not going to accept any of that stuff. It's all through eCentennial, okay? So that's one big change. The other major change is during exams, one thing that I will be doing is allowing you to access everything. Google, you know, do whatever. It's okay. And the reason for this is because it won't help you. Google access is not going to help you. And access to all your slides and stuff like that is not going to help you unless you've practiced and you've been doing this stuff on your own. You need to continuously practice to be good. You'll be under it'll be a timed exercise again. You won't have a lot of time to do the exam, and you need to know what you're doing. So access to Google is not going to help you at all, right? I mean, not that much anyway. So that's something second. The second thing I do that's different. The other thing I do is different is I have my PowerPoints, and all the stuff that I'm going to be talking about at a very high level is on my PowerPoints. But I'm going to be demoing stuff outside of this stuff. The PowerPoints are for you. They're not for me, right? So there's just materials for you to look at. If you don't have the book, if you don't have access to the book, everything that's on the PowerPoint is fair game for the exam, right? It's up to you to read them, go through them if you need to. It covers the topic that I'm going to be discussing in class. Okay? Questions around that? Sorry? Yes, of course, theory. That's what I'm going to be talking about today. So part of the theory here today is that the idea of that classes, again, this is a review, and I'm going to assume for today, here's my assumptions I'm going to make today. You don't know anything about classes, right, for a second, although I know you know, right? You don't know anything about Visual Studio, right? I'm not going to assume you know Visual Studio. I'm going to start out Visual Studio like you've never used it before. And I'm also going to be, I'm doing that for a reason, because I have a different way of doing things. The way I do my naming convention is different than Narendra's. So I'm going to ask you to learn it my way, right? Imagine now that you have a new manager. His name is Tom. You had your old manager, Narendra, and he got promoted. He got moved somewhere else in the company, right? Now Tom is here, and Tom's doing things a different way. You got to adapt to your new manager. I'm the new manager, right? All right, cool. So classes are blueprints. We use blueprints to create objects, right? Real life stuff. In a real life, this would be like what we like. These are plans for a house, right? Plans for a house are not the house. The house is the house. The house, in our case, represents the object. The plans represent the class. The plans are technical specifications for what we're going to be building, all right? That's what they are, tech specs, right? They also are, all our business requirements, our customer requirements are going to be outlined here with a representation of a class, okay? So what about inheritance? What the hell is that, right? When we talk about inheritance, which is the topic of today, think about inheritance as extending a class. I've got a class, I've got a diagram that I've got for the class, I've got a plan, and now it builds this first house, let's say, right? But let's suppose I extend the class. Here are the keyword, because I'm going to ask you this on an exam. I'm going to extend the class, right? And it's going to, the output, the object of the new class, right, is going to look like this. It's going to be bigger. And I always want you to think of that. When we talk inheritance, I always want you to think that the base class, this one, that's the keyword, base, is always going to be bigger than the derived class over here, right? Base class also can be called superclass, right? Superclass or parent class. Parent class, superclass, base class. Those are all the same, right? Child class, derived class, subclass. They're all the same. You need to know these terminologies, because it doesn't matter whether you're doing object-oriented programming in C# and object-oriented programming in Java or JavaScript or something else. You need to understand this. You might read a manual that says your parent class. Don't be confused. It just means base class, right? In C#, we're going to use base class and derived class, okay? But it doesn't matter. You should know the idea. So base class is smaller than the child class. Parent class is smaller. See, I'm mixing it up. So, you know, parent class, right, is smaller than the child class, right? Parent class is smaller than the derived class. Parent class is smaller than the subclass. It all means the same things. Okay? Let's talk about other things. I also want you to think about the child class or the derived class as a more specialized version of the parent class, right? So here's an example. I've got the idea of a real-world example of this animal, right? Animal is a very generic word. It doesn't really mean anything, right? Not really. I mean, we can classify a lot of things as animals and some not. Maybe this isn't even correct, fish as an animal, right? But if you think about it, an animal is something that's very generic. And here's a mammal that's more specific, right? And here's fish, more specific. A mammal, though, is not a fish. They're side by side. They have the same parent class, but they're very different specializations of the parent class, animal. Does everyone see that, right? Again, I'm using real world kind of, how to translate something in the real world, something more specific from a coding perspective. If you go down the inheritance chain here, right, you can see that bird is also, could be a mammal, right? And so is tiger, but they're very different mammals. Again, two different specializations, right? And as I go further down, parrot is a type of bird, because bird is a very, very generic way of talking about things, right? And dove is a more specific version of bird. So parrot and dove are more specific versions. They're the ones we're going to use. Bird is very generic. Mammal is very generic. Animal is very generic. But notice these ones here, they're all specific. So as you go down the inheritance chain, you get more and more specific until you get to a class that you're going to be using. Okay, so some really good things. So let's talk about some things that are really great about, some great things about inheritance. Can anyone think of something that's really awesome about inheritance there? I think about this now. I define an animal, and then I inherit stuff. Everything that the animal class has, the mammal class has, the bird class has, and the parrot class has, right? I inherit all those things. I don't have to recode all that. I only code it once, and I have all that stuff inside the parrot class. So the parrot class has everything that all these other classes have. So that's a good thing. What's a bad thing? Oh, how about this? We'll go back to good thing. How about another good thing about this? Naming conventions. Okay, so conventions. What else? Anyone else think of what really good things are when you have inheritance? Why do we want to use inheritance? Naming conventions is almost like rules and structure, yeah? I'm not doubling my code. I'm minimizing my code because I'm defining something once and I'm using it again and again, just like I do with methods, right? But this way, I'm kind of reusing my different classes everywhere else. Yes?
You also have relationships.
Relationships, right? A mammal is an animal. It's got an is-a relationship, right? Same thing with a bird. A bird is a mammal, but a bird is also an animal, right? Because of the inheritance chain that we're talking about here. Now, guys and girls, we're going to be talking about this in more detail today and next week, right? I'm not going to just end off inheritance today. It's a very important topic, right? And we're going to continue moving with it over the next week or so. Okay, so animal, mammal, bird, parrot, no problem. This is good. What's a bad thing about inheritance? Really bad. Take a look at the diagram here. What I've got, it looks like a pyramid, right?
Carries the weight of everything before.
Carries the weight. You were in my last class. It carries the weight of everything before, right? That means if animal is really a fat class, mammal is fatter, bird is even fatter, parrot is really fat. And when I say fat, I mean more lines of code. More lines of code. Always, always that the bottom classes here are way fatter or bigger than the animal class, the top class, right? That's bad, right? That means that my code can get really big and fat. When I make a parrot, it actually has all this code all the way in it in the background. I'm reusing this code, so it's fat, right? What other things? What other things are negative about inheritance? Anything else? Can you think of that's negative about inheritance?
So if you have an error at the top of the chain, does that carry over as well?
Yes, that's a real problem. So the question is, if I have an error here, then I have breaking changes that breaks everything else. That's a real thing. This is if you think about this, this is a single point of failure up here, right? This animal, if I break animal, I break everything. I can break my code. I can break my my build, if you will, right? By just breaking this. That's bad, right? The other thing that's really bad is, again, we have a lot of these. I mean, that's the main thing, though. The main thing is this whole domino effect, right? And it's also a very strict structure. There's certain things you're going to notice today when we do our demo that I need to do all the way down the line in order for me to use the stuff above. Okay, so it's strict, and it kind of puts us into a box. A lot of times we want to avoid using inheritance, right? We want to do some inheritance, but for the most part, we want to use something called composition, right? And composition is a different design pattern, right? Where we talk about, I might have an animal, but maybe I don't need everything in mammal. One of the questions I had from the first section was, hey, do I have to inherit everything? The answer is yes. You have no choice. Everything from animal comes into mammal. Everything from animal comes into fish, right? But what if I don't want everything from animal, right? Well, too bad. Once you inherit it all. right? So one thing about in the real world is we have parents too, right? But this idea of parent and child relationships, right? But in the real world, you need two parents to make you, right? They have sex, just put it out there, right? And then all of a sudden, poof, you just exist, and 9 months later, if you're lucky. And if you're lucky, you exist very, very nicely. You don't have any problems, right? But here in computers, there is no sex, right? There is no, well, there is, but there isn't like that, all right? What I mean by that is you only need one parent, right, to create children, right? There are no two parents, and that means that there is no multiple inheritance, multiple parent classes for one child class. It doesn't happen. It creates sometimes it creates conflicts in some programming languages that allow it, right? And it makes it very complex because now I'm inheriting both things, much fatter too, right? Inheritance is bad enough as it is. For us to inherit from two different things is really bad, right? So we kind of move around this idea of multiple inheritance, or even making our classes slimmer, right, by using interfaces, which we're going to get into next week, all right? So that's the thing that I want you to note. Other things to note are constructors, which we're going to see later on today. You guys should all know what a constructor is for a class, I'm assuming. Yes? Well, when I make a constructor here that's not the empty constructor, then this one has to, your base classes have to use the base constructor. We have to call the base constructor, which is something that's new that you've never done before, okay? Which we're going to see. And that means all the way up the line. All right, it has to satisfy the requirements of the base constructor. So if there's only one base constructor and it takes 3 arguments, you must have a constructor somewhere inside of your classes that take 3 arguments. You have no choice. It's required, right? And that, again, puts you into a bit of a box, right? So inheritance at a very high level. These are the things I'm talking about today, right? And I'm bringing this up because I want you to understand them, these things, okay? Questions at this very high level, what inheritance is. Again, the idea that the class is a blueprint is very, very important because this is our design. And you can see that when our design changes, we add stuff, we extend the base class or superclass or parent class into something that's fatter, that's bigger, right? All right. One of the things we're also going to be covering other than these topics over the next week or so is the idea that when we code, this is on a different topic now, when we code things, a lot of times up until now, you've been coding it with your machine. And who's ever run into problems where they said, oh, my machine broke and I lost my code. I lost my USB and it's gone, right? Or I don't know what I did, but it worked just now and now it's not working anymore. Anyone have that problem ever? I sure did. I'm going to put my hand up. I'd have that problem lots of times, right? We have to stop doing these things, guys and girls, right? And to avoid doing that kind of stuff, I'm going to be introducing a new topic for you guys today as well as inheritance. And it's GitHub. GitHub, right? And the idea that GitHub, I'm just going to put it up here so you guys can see. I'm going to use an incognito window for this one so you guys can see what it looks like. I want you to all subscribe to or set up an account with GitHub, built for developers, like it says, right? GitHub is a place that we can share all of our files, and I'll be sharing all my files with you going forward, right, on GitHub as I code. So I need you guys to set up an account. It's free. One thing I also want you to get is the student pack. Let me see if I can get that. The student pack for GitHub, right? Student developer pack, which is right here. If you go to education.github.com/pack, right, you can access the GitHub education pack, which comes with a lot of little extra things, right? You click on Get Your Pack Now. And what it also does is gives you unlimited private repositories. And I'm going to talk about what those are, all right? So I want you to get those 2 things. So by next week, because the next lab we do, remember I talked about I'm not doing Narendra's labs exactly as they were. And I'm not doing his assignments exactly as they were. But some form of them are going to come back at you. They're all going to require to use GitHub. Everything from now on, including your exam, you need to use GitHub. There is no option for this. It's not like, I don't know GitHub, Tom, so I can't use it. No, no, no. I'm going to be teaching you GitHub over the time, right? So you need to do this. The requirement is an output from this course. Why? Because when you get to the next courses, especially if you do courses with me, with Wallace, with other professors. It's going to be reintroduced to you, and you need to know how to do it. When you do your capstone project right here at the college, you're going to have to use GitHub. So it's better to you learn it now than find out about it later. And it's a good practice. Nowadays, we use GitHub in the real world to kind of, as an interview thing, right? I mean, I want to look at your code. Show me your code. Show me examples of your code. You're not going to show me your project. I want to see your code, man, right? And the best place for you to showcase your code is here on GitHub. So if you build it up from now, what are you guys in semester 2? Build up your code now on GitHub, and what will end up happening is, later on, as you leave college, you're going to have a good collection of code that you can show your interviewers, so you can get a job, right? It's not enough nowadays to have a good resume. Your resume must have some context, and part of it is having a GitHub account for developers. And all of you guys in the room should be, in some ways or another, a developer by the end of the time here at Centennial. Okay, so sign up for GitHub. But what the heck is GitHub anyway? And what is Git? And what is all this stuff that I'm going to be talking about? Well, for this, I'm going to pull up one of my favorite drawing programs, Fireworks, and I'm going to draw it out for you. But people that are not here physically, and this is what happens when I record, everything that's on my screen is the stuff that gets recorded onto YouTube, right? So I have to draw it sometimes. So let's do this thing. I'm going to make a new, kind of a new file here. So I'm going to go File, New. Oop. Not new from template, Tom. I meant new. There we go, File, New. And sure. And I want you to think about GitHub. Remember that primarily I do a lot of games. You will see games in your assignments. There will be something to do with gaming, right? Even though you're not a gamer, I'll be asking you to do something. I'll give you that kind of simulation. I won't ask you things like, as an accountant or as a bank. I'm not going to do those scenarios. It's going to be about games, right? That's what I do. All right, so think about this. I have a computer, and let's suppose the thing I'm drawing here, which will come up eventually, which is blank, which is because I have there we go. Woo, okay, good. Problems when we do this kind of stuff. Let's make this also blank. I don't want any kind of in kind of stuff in here, and make this a little bit bigger. Okay. Ah, woo, there's my local environment. A lot of stuff to draw, right? So let's suppose I have my local environment right here, and your computer is right here, right? It sits right here. So this is your local environment, so local. And in my local environment, I have my files and folders, right? So I have another set of, no, don't tell me, it's going to do it again. I have another set of files and folders here, right? Bear with me while I talk. Make this 4 again. That are here. So this is your folder inside your local environment, right? And this is your folder structure. And this is where you have all your files. So think about this. I'm just drawing pictures for you guys so you can see. So this is your folder, right? In your project folder, actually I'll call it project folder. In your project folder, you have all your files, right? So imagine now if my computer, so this is my local environment, my computer breaks, file's gone, right? Now in a real world scenario, if this is how you worked, and you lost all your files on a big project, this could be sometimes considered something like a resume generating event where you become fired, right? That could possibly happen for you, right? So please, whatever you do after today, start thinking about storing your files in other places. Now, some people might say, well, Google Drive is enough, or Dropbox, or on my USB drive. These are all bad solutions, all right? This is not a professional level kind of solution for developing, right? So what we use is something called GitHub. Now, GitHub is, and GitHub is a cloud service, but Git is something where we take a snapshot of your local files. I'm just going to make another kind of circle here. So here's my project folder, and what I want to do here is I want to take a snapshot. So here's my snapshot. No, it's not black. It's not black. I swear, my snapshot is not black, right? My snapshot is just a snapshot. So let's suppose I have a snapshot of my local files. Here's my snapshot. And it happens at a particular time in, when I'm coding, right? So snapshot, every time I add something in, I create a snapshot. Every time I modify my code, I create a snapshot. Well, these snapshots of my code in my project folder are called commits, right? So that's what they're called in GitHub talk or Git talk. Commit, right? So a commit is just a snapshot of my code. Why would I want to make a snapshot of my code? Because every time I make a change, right, I want to kind of capture that change, right? So if I want to, I can go back, right? So there we go. So there's two reasons right there where I want to use Git. And there's a third one for GitHub. So this is Git, lowercase, right? The idea that I can have a revision control system, right, that's local to my machine, I can use something called Git to do that, right? So Git. All right, so Git, I use my Git system so I can make a commit, a snapshot of my project folder. And the snapshot, right, the commit is stored in a repository. So this is a repository. Repo, right? The repo is actually in the hidden .git folder. And this is inside of your folder, inside in your Windows machine, right? When I make a snapshot, right, it's hidden in a .git folder inside your project folder. That's what it is. Okay, are we good still? Commit, snapshot. Your repo, your repository is just a .git folder that's hidden inside your project folder. And this, we're using Git to do this, to do all this stuff. Okay. Now, by default, Windows does not include Git, right? And we're going to be talking about how to get Git later on. Okay, so this is local, but what the hell is GitHub? I mean, I told you to sign up for GitHub, right? So let's talk about another ellipse. Hopefully it's, yeah, I did it again. See what happens? And forgive me because when I'm drawing, it's really painful to draw without a stylus. But let's just talk about this cloud idea, right? So here's the cloud, right? And let's make it black, right? Just so that we're drawing like on the board. Let's make it 4. And let's suppose that this cloud, this circle right now, is GitHub. So what's GitHub? GitHub is not your local environment, right? GitHub is a cloud provider. That's what it is. So this is a cloud provider. Just like Dropbox, software or platform as a service, just like Google Drive, just like OneDrive, just like iCloud, right? That's what GitHub is in a way, right? But it doesn't store files and folders the way that GitHub, that Dropbox and Google, Google Drive and all those things store things. It creates a repo. It stores repositories, the whole repository. Okay, so GitHub is a cloud provider, and it has a repo. Right, so it has repositories. So it has more than one repository for each of your accounts. So you have an account, and your account has multiple repositories. Each repository relates back to some kind of project that you created, right? Are we good so far? So to connect to this cloud provider, GitHub, we need to create something called a remote. And it comes from your local environment, right, to GitHub. And this is called a remote connection. Again, please forgive my crude drawing. But this is why it's recorded, so you guys can see this later on, right? So this remote is just a connection between your local environment and GitHub. That's what it does. When I have my remote created, I can do a couple of operations, right? I can do a couple of operations. One of the operations I can do is I can do a push, right? So I can push. GitHub, it's like uploading. I want you to think about it as I'm uploading my files to GitHub, right? And likewise, I can also do a pull, right? Pull downloads from GitHub, right? Now, why would I want to do these things? Because if I want to store my project, I need to push it into a repository. First, I need the repository created. That's the first step. And after I've got a repository, a container up here, right? And that's what these things are. They're containers. They're not directories. It's not like you can modify the directory like you can with Google Drive. It's just a container for your files that you put up there, right? So why would I do all this? Well, because there's 3 real reasons to use GitHub. And the first reason is, of course, backup. So I'm going to say backup. That's like reason number 1, right? And the second reason right, is, of course, version control, I would say. So version control, also called revision control, right? The revisions of each of your files. And the last reason would probably be, if I was going to specify it all, collaboration, which is what I talked about earlier, which is you want to share your files with the world, right? In open source projects, we work with a lot of open source projects. We collaborate on GitHub, okay? The other provider that's really popular out there, GitHub is the most popular, but there's also Bitbucket. And you may have heard of one or the other. And there's others, okay? So those are the three things. I'm going to be testing you on this on an exam, guaranteed. If I ask you the 3 reasons to use GitHub, it's going to be backup, version control, and collaboration. It doesn't have to be in that order, but those are the main reasons why we use GitHub. So is GitHub and Git the same? What do you think? Is GitHub and Git the same? Yes or no?
Yes.
No. No, it's not the same. Git is the version control system, and we can use that locally, right? And we can use it to connect remotely to our GitHub cloud provider. GitHub is the cloud provider that uses Git, right? But Git is the system. So Git is our revision control system. Here's our version control system. That's what this thing is, right? Cloud provider. 2 different things. Okay? Still uses Git, but it's not Git. It's GitHub. Questions around GitHub and Git? Let me make this a little smaller for you guys to see. This idea, this picture, is a very basic, high-level picture. It's the very beginning. It's like Git 101. There's many, many, many other things to do here than just do this. We can use Git for project management. We can use Git for developing milestones. We can use Git for agile methodologies. We can use Git for a lot of different things. What I'm talking about is a very basic use of Git, okay, which I will be doing today. And you'll be doing going forward, right? So step 1, you need to have an account. So please sign up for Git. It's free. Get your student developer pack because it gives you private repositories. That's number 2, right? And the third thing is you're going to be using Git and GitHub every time you upload your files, okay? So there's going to be 3 things I'm going to probably ask you for, right? When you hand in your assignments from now on, a link to your GitHub repo, right? Your files, all your files zipped up inside of like a zip archive of your files. I want them all, right? I'm not going to ask you for paper copies or anything like that. And it's going to be the same between all my assignments and the exam, right? Prepare you for the exam. If you don't do your assignments, you'll have trouble with the exam, all right? The assignments will be individual for the most part, right? As you go towards the exam, and the exam will have something to do with inheritance that we're going to be talking about, as well as any other topic that we're going to be covering. It will be a practical exam, and there may be some questions. I may break it up over 2 days. So it might be like exam part 1, exam part 2. Exam part 1 might be like 50 questions around this stuff. And exam part 2 might be, show me your work. Show me that you know what I'm talking about. Okay? We'll see how it goes. All right, so questions around GitHub or anything like that. I'm going to ask you questions later on. So if you haven't paid attention, I'm going to try and embarrass you and ask you, like, what are the top 3 things that you use GitHub for? Coming. All right. All right, so so this is one part. Now, when I talk about inheritance, right, and I'm just going to go back to the PowerPoint for a second because I'm only going to talk a few slides today, right? Really, we talked about what the idea of inheritance is. Just like we inherit from our parent, right? We inherit stuff from our parent, and there's good reasons to use it. It's like it says here. We talked about this: saves time, reduces the chance of errors in some ways. Sometimes it creates errors. If you have an error, the base class, everything else has an error, or you can make a bunch of breaking changes to your entire application. Yes, it does make it easier to understand the inherited class, right? The whole advantage of inheritance because it has a relationship with the parent class. An example that I showed earlier of an employee class. Okay, it may be hard to see, but I'm going to zoom in here for a second. So let's suppose I have this employee class. Here we go. Notice the employee class has a couple of private instance variables or fields. That's what they're called, right? And then plus a couple of properties, right? A couple of public properties. Again, this is adhering to the whole idea of private instance variables or fields, public properties for information hiding. That's object-oriented methodology 101, right? You guys should know that already, right? So these fields, notice that they have a lowercase e for empnum, employee number, and then there's an uppercase E for employee number for the properties. Yeah, this is nice. I won't be doing this, right? What I'll be doing is an uppercase, so upper camel case for the property, lower camel case or just camel case for the instance variable with an underscore in front of it. So there'll be an underscore. Every time you see an underscore, it means private, right? So when I code my stuff, you see that, and when you code your things going forward, I want to see an underscore in front of all of your private instance variables or fields, right? So I can instantly see that it's private, right? Why would I do this? Some confusion later on. Now it's just a convention, and some coding houses like it, some coding houses hate it. So it really depends on the coding house you're part of. Guess what? You guys are all part of my house, right? So you're going to be doing underscore, right? So everything you make is have an underscore in front of it. This is our new standard that we're going to be taking on. Notice that we're using this idea of a property that's not the short version of the property. It's the long version, right, with getters and setters. These are called getters and setters. They're also called get accessor methods and set accessor methods because they are methods. That's what they are, right? Notice that the get requires a return. Again, this is just review. And that the set uses this keyword called value, right? And what value is, it's anything that you assign to this property. So if you say empnum equals, the assignment operator equals, and some value, that value is going to be stored here in the value keyword and passed into the empnum private instance variable or field. So are an interface to connect to our private fields up here. Fields store data, properties are interfaces to connect to the data. That's what they are. And that's how we're going to use them from now on. Okay? Are we good? Again, this is all review. You guys should know this with classes, you guys and things we've talked about before. This is all stuff that we're going to see again. Okay. So think about this. When we talk about inheritance then, right? We talk about employee, that's the base class. And in this case, when you look at the diagram, you can see that there's a couple things, right? One, you've got a couple of private instance variables here, and then a couple of properties here, getters and setters, and then you have a getGreetings method down here. The getGreeting methods and all methods describe some kind of behavior that the class is going to perform or has the ability to perform, right? getGreetings. Okay, that's the behavior. Now here's our subclass or child class. Our child class has this arrow that points to the parent class. That is proper notation to say, hey, this child class inherits from the parent class. In fact, this child class is a employee. It's just a specialized version, right? Like we talked about before. A commission employee is a specialized version of a regular employee. And not only does it have all this stuff up here, but it also has commission rate, which is another property, another instance variable, and commission rate, capital C, which is a property. All right? So there's two extra things that this subclass has that the superclass does not have. And so therefore the subclass is fatter. It's bigger. The shape is different. All right? It's not the same shape as this one. It's similar, right? It has some similarities because it has all this stuff in it, but it also has all this stuff. So why would we do this? Why the heck are we using inheritance? Why not just make a commission employee class in the first place and have everything we need? Because what if I had a non-commissioned employee? Or what if I had other types of employees, managers, and whatever? There's different kinds of employees, and they would be separate and different than this one. They have the same things. There's a lot of similarities. I don't want to keep copying this over and over again, right? I don't want to keep replicating this exact thing because every employee is going to have these things, right? And that's why it's good to use inheritance. The same reason why it's bad to use inheritance. All right, so some terminology. Base class. We talked about this. There's three ways to say this thing. Base class, superclass, parent class. Right, you need to know this. This is terminology for you. Derived class, right? We're also called child class and subclass. Those are the three things, right? The way we talked about it. For us here in C#, we're going to use base class as the superclass or parent class, and derived class as the child class or subclass. Okay. Notice that it says in here that it has an is a relationship with the base class. That's what the derived class is. So you can always say that the child class is a whatever the parent class is, right? But a more specialized form. Okay. Any questions up to this point? So that's what really inheritance. Let's try some stuff because watching me is really boring. Let's do it together. I'm going to pull up something else here. I'm going to kind of go here and go File, New Project. All right. There we go. I'm going to make a new console application. Notice that here I'm assuming you've never used Visual Studio for a second for a reason, because I got to tell you some new things about it. I'm choosing the console application template in Visual C#, right? And I know we had some problems with that in the exam. Some of you couldn't do the console application because the machine was broken, but you should be able to do this. I'm going to name this console application COMP123-Summer 2017. That's my coding, and that's the exact same way my videos will be coded, as well as my GitHub repositories, right? So Summer 2017-lesson 8B, you guys are the B team, no disrespect, right? The A team was just the section before you, right? And notice that it says I'm putting it in a folder called COMP123. That's just me. You can put it wherever you like. Also notice on the right-hand side that I am creating a directory for the solution, and on the bottom, this is new, that I am clicking on Create New Git Repository, but you may not see this right now. You may see Add to Source Control. And the reason for this is if you've never used source control before, it'll say Add to Source Control for the first time. Click on that. Make sure that it's checked. All right. I'm going to click OK. What this is going to do is it's going to create my new solution. So here's my new solution, right? Right here. Now, please forgive me if mine looks a little different than yours. And I'm just going to turn the lights down so you can see what I'm doing. We have a lot of glare. We have a lot of glare in the class because of the lights and the light in the class, and I apologize, right? So I have a couple of things here. I have this driver class. Have you ever heard of it being called the driver class, a program? That is the word we're going to use. The driver class is the program class. It drives the rest of the application. Without the program class, the static class, right, your application would not function, right? It doesn't have to be instantiated, this class. It just creates the instance of my program, the rest of my code, okay? We use it to drive the rest of the code. So this driver class right now is empty. And I want to create my new class. How do I do that? How do I create a new class? Please forgive me. I know that you guys know how to do this, but I want to know from you guys. Show me, tell me what to do. What do I do? Right click. Yeah, and then add, yeah. And then down here, class. I could do that. I could do class. Notice that it's here for me. I could go to new item, right? The reason why I see some extra stuff down here than you do is because there's certain things I do more than you, and this is my quick hit menu. If I click new item, I can certainly choose class. Here's my class. Now, Narendra asked you to make a library. I'm not going to make you do that. It's just going to be a class for now. We're going to rename this thing. We're going to do a classic example here. We're going to make the person class. Let's do that. Person. And add it in. Cool. We got a space for person. All right, cool. This is a great place for me to add things to GitHub. I want to add my stuff to my GitHub repo. Well, wait a minute. I don't have a GitHub repo. What do I do? Well, if you click on Team Explorer, and if you don't have this on the right-hand side, Team Explorer, right, you can go to View, and then Team Explorer, and it'll bring up the Team Explorer window. Now, here's a chance. You may not see what I see. You may not see Publish to GitHub. If you don't, that means you're missing something. And the way to get that is if you go to Tools, and if you go to Extensions and Updates, right? So if I go to Extensions and Updates, and if I go to Online, right, and I choose from a search value perspective, Git or GitHub, you should see this, and that's what you want. You want to install GitHub extension for Visual Studio. Please do this now for the system in front of you if you don't have it already. If you have it already, leave it alone, right? If you don't have it, though, you need to get this GitHub extension for Visual Studio because I will be using it extensively, right, for the remainder of the course. And I don't want you to be left behind. So please do that now. If you have it, We're all good. But if you're using your own laptop, and does anyone not have a laptop? Anybody? It's okay not to have a laptop. If you don't have a laptop, you're going to have to be using the system in front of you. And you may, if you don't have this already installed, you may have to make some changes as we go. Okay? But if you have it installed, you're good to go. There's nothing for you to do in Windows. Just get this extension for Visual Studio. Okay? Once you've got it, you should see your Team Explorer look like something like this, where you have published to GitHub. Okay? So again, I went to Tools, Extensions and Updates, right? And then from there, I went to Online. And then from there, I searched for, in my search area, I searched for Git. And then it brought up the GitHub extension for Visual Studio. Okay? By the way, it's not just Visual Studio, this 80 million lines of code IDE that has Git integration. Most other IDEs in other languages all have Git integration these days, especially things like Xcode if you're programming in iOS, right? Or name the IDE. It has GitHub integration, right? Okay, cool. So we have GitHub. Here's GitHub. And I want to publish to it. Well, guess what I'm going to do? I'm going to click Publish to GitHub, right? Now, the great thing is once you connect, it'll ask you some questions here. It'll say, please log into your GitHub account. You need to have a GitHub account in order for you to do this, by the way. That's why I said get a GitHub account, right? But once you've logged in for the first time, it'll give you a view into your GitHub account. And if you notice here, I'm looking at my first account, Studiopolis. You will only have one, right? I have multiple accounts. One of them that I want to look at is Centennial College, right? And this is where you'll be looking up on GitHub. And an example of that would be if I go to, that's the wrong thing. If I go to GitHub, right, you're going to find that if you go to Centennial College, right, so github.com/Centennial College, you'll see my repositories for all of your work, all the things we do in class together. Notice that you see lesson 8A. That was from first section, right? I'm not going to be using P drive, H drive, X drive, whatever you're going to call it. No, it's not going to happen. Everything is going to be up here on GitHub because I want you to start using GitHub, okay? So it's going to be on github.com/Centennial College. I will put the link up on eCentennial later on today, all right? So I want to put it here, right? And if I go switch back to, by the way, I'm using a Mac. I'm virtualizing Windows. That's why I'm switching between the two, right? I want to put it on Centennial College, and I want to call it COMP123 S2017 Lesson 8B. Notice the same name as my project, right? If I click Publish now, and if everything goes well, and if I've already signed into GitHub, might ask you some stuff, some sign-in stuff. It's already created my default account, and or my default repo. Now, I've made some changes. Remember, I added a person class right now. Here's my person class. But what I'm going to do right now is I'm going to say, I'm going to create an initial commit. This is kind of my initial base level snapshot, if you will, right? Now, there's two ways to name this thing. You can always name it initial commit or first commit. That's the convention that we all use, okay? Initial commit or first commit. You can call it whatever you like. Please don't call it A, all right? Please don't just drop in some random stuff. When I create the name for my commit, what I'm doing is I'm naming my snapshot. That's what I'm doing. And it has to be intelligent the way you're naming it, all right? Make sure it makes sense. Whatever you've changed, kind of try and put it into the snapshot. Make it a short description. Don't make it too long. It's got to be like something like 15 characters long, something like that, or 20 characters. Don't make it too big. All right, cool. So this is my initial commit. I'm going to commit all. This commit all button. Say yes. And then I'm going to click on my home button here in my Team Explorer. And I'm going to click sync. And then I'm going to click push. Remember I talked about push for GitHub? I'm going to push. So what have we done? Let's go back to this repo. First of all, do I have the repo? If I refresh. Yes, I do. Now you can see that I have 8B. Here's 8B. It was done 21 seconds ago, right? Here's 8A. Here's 8B. What's in my 8B? Well, I have 3 commits, right? Where did those 3 commits come from? 2 of them were from Microsoft. I didn't do this. This is Visual Studio doing this, these 2 commits automatically. When you click on that add to source control or use Git. All right, this is my commit. This is my snapshot. So actually we have 3 snapshots here that we've taken so far for our code. People, just to let you know, this initial commit is like a backup. If all you do is this, you lose 3 marks from your final assignment. And I'll tell you what, backup is only one thing I want you to use. I want you to use Git as a developer. I want you to develop with Git, which means, and GitHub, which means as you make changes, I want you to push to GitHub every major change, okay? That's the habit that I want you to get into. So you make a change. I added a class. I'm going to make a commit. I make a change to the class. I add a commit. I add a new class. I make a commit. And I keep doing that throughout the entire time, so that way I can keep track of all my changes, right? And worst case scenario, I can jump back if I made a mistake, right? Or I can look to see what I did that made the mistake happen. Okay, cool. So this is good. I've got this up on GitHub now, right? And let's take a look at my code. With my code, I can step into GitHub. So if I actually look in here, and you guys please follow me here, go to github.com/Centennial College. Take a look at my code, please, so you can see what I'm talking about. You'll see the code that I have. It's not very much, right? But if I click in my folder here, and if I go into my person.cs class that I made, you can see an empty class, yeah? Like this. Here's my empty class. This is what you should see right now. Okay? This is how I will share things with you going forward. All right, cool. So I've got my class, my driver class, and here's my person class. And what I want to do is talk about inheritance, right? Well, first, let's give some comments to my class. And the way to do comments, I will be asking you to do this on your tests and on your assignments. Minor comments I'm talking about here, not too many. I'm going to do the // here. So my cursor is above the class. And I'm going to do // 1, 2, 3, boom, which adds in the summary. And I can say something like, as simple as this is the person class, right? Just a comment, right? My person class itself is pretty lonely right now. It doesn't have much of anything. I definitely want to have some private, right, instance variables. What's another name for instance variables? Come on. Another name for instance variables. You can answer if you want. Huh? Fields. Right. So private instance variables are fields. That's what they are. I want 2 of them, right? Here's my private, right? So my person, what does he have? He or she has a string, which is a name, underscore name, right? And private, right? We'll use an integer for now, underscore h. A name and an h, yeah? Classic example, by the way. If you can see this online, 10 different places, right? All right, cool. So now I need some public properties. Now I could use the prop keyword, P-R-O-P, right? And then press tab to create my my property. But we'll do it the long way today. All right. First of all, let's make some comments. We'll say public properties. Right. Here's my comments for my private properties or my public properties. And then under my public property area, I'm going to put in public, right? The name of or the return type, which is going to be string. The name of my property, which is going to be called capital N for name, right? And then inside my property, I want to have a getter and a setter, or a get and set accessor method, okay? Notice that my getter has a problem. What's the problem? I need a return type, yeah? So I need to put a return type in here. Return, what is it going to return? Well, here's where I do things differently. I don't just want you to put underscore age. I'm going to be using the this keyword, this underscore age, right? It's very explicit. That's what it's going to return. Okay, I've got a problem. It says, I don't know why, but this has a problem. It says, this is the person class cannot implicitly convert type int to type string. Well, why? Because I made a mistake. I don't want age. I want name, right? Some good hinting there, right? What else? For my setter, I want to do the opposite, right? I want to say this dot underscore name, right, is equal to value, right? Which is the value is a keyword, all right? Value is a keyword. It means that whatever I assign to my name variable, my name property is going to be the value. The literal is going to come in here and it's going to set it. Right? Make sense? So very, very high level. Good. Next. Let's add another public property. Public int age. Up here so you can see this, right? And again, I want a getter and a set accessor method. And inside my getter, I want to return this dot underscore age. And my setter is going to set age to value. Cool. So I've got a couple of properties and a couple of instance variables or fields, right? And inside my properties, I have more control. These are methods. That's what they are. That's why I call them accessor methods. I can do other things in here other than just setting. I can write line every time that you set them. I can do all kinds of stuff. I can add counters to something else. I can call another method. I can do a bunch of stuff in here because they're methods and they give me more control. I never want to directly access my instance variables again. It's all going to be through my properties. Okay, cool. Again, this is just review 101, classes 101 at this point. Okay, cool. I'm going to go down and I need, you know what, a constructor, right? So here's my constructors, right? Here's my constructors. And now by default, I have the empty constructor, right? Which is just the name. How do I make a constructor again? I could, but I want to type it the long way. How do I make a constructor? What do I need? So I need public for sure, right? And then I don't need void for a constructor. The name of the class, which is person, right? And the base constructor is this one, but I don't want this one. I want to take two properties, one, which is a string, and the other one, which is an integer. And what I want to do here, this is a classic example again, is I want to say something like this. This dot. Now, what should I use? I just said it earlier. Should I use the instance variable or the property? What should I use in here? Should I use my private instance variable or the property? Huh? The instance variable or the property? What should I use in here? I can't hear you. I don't hear. I'm not. What do you think? The instance variable or the property? Properties. Please use properties here. So which means this dot name is equal to name. So basically what I'm saying is this name here, which is an argument, right, is going to the value of whatever's coming into the constructor is going to be set to the property, right? The property is going to be take the whatever value it is and it's going to be set to it automatically. And this is going to happen. When do constructors get triggered? When are they triggered? When I create my object, right? So when I create my object, when I instantiate my object, the constructor gets triggered. And not just any constructor, the appropriate constructor, whatever that constructor is that's being used to create the object or instantiate the object. Okay, cool. So I've got these two things. So my constructor, well, you know what? The great thing is not only can I do this, the default comments, but if I put // now, I can see that it gives me a couple of extra stuff. It gives me the name and age as parameters that I need, as well as something like this. I can say this is the constructor for the person class. It takes two arguments. I mean, you can put as many comments here as you want. I'm just giving you some examples of what we're going to be doing, and I will give you a methodology for what I want, which is name, which is a string, and age, which is an integer. And of course, it doesn't return anything because it's a constructor, right? And that's your constructor, right? Cool. My person class. Okay, now I've got everything. Now I've got almost everything I need for a real class, right? The other thing I really need is some kind of public methods, right? I remember that my methods, my public methods, right? Methods are behaviors, right? That's what they do. They give us behaviors, right? So we can't do our, you know, we have a class. If all it does is a place to store data, okay, it's okay. But really, a class should have some data storage capabilities and some kind of behaviors, right? And the methods provide that behavior. well, let's say it's a person can talk, right? So we'll just say public void, well, doesn't return anything, but it talks, right? So the person talks. There we go. It's a very simple example. I'm going to use the write line. What's a shortcut for console.writeLine? Yeah, right? Console write line. And we're going to say something like, well, this dot. Now, what should I use here? I want to use the name of the person. Should I use the instance variable? No, it's the property, right? This dot name. We're going to use concatenation in this case. We're not going to use some kind of formatting just for today. And this name is talking. Right? Yay! The name is talking. All right, cool. So the name is talking, whatever that name is, the person's name, right? And we have a method. Now, if you notice here, we could also do the // so I can go just for commenting, // it gives us a summary. This method allows or enables, we'll say enables instead of allows, enables the person object to talk. Now, in real world, it wouldn't just say is talking. In a game environment, maybe it would have some kind of, some kind of talking capability. I don't know. All right, so that's our person class, but we need to test it. And we're going to do that in the driver class. The driver class is the program.cs file. Right, so here we are in the driver class. And in here, I want to instantiate a new person, and I can do that. I can say person is the type, lowercase person is the object, right, is equal to a new person, uppercase, and then take a look what I get now, because I put that information in the comments, right? It says, this is the constructor for the person class. It takes 2 arguments, name, string, and age, right? So the more details you put in your summary, the more the user, whoever uses your class, gets an idea of what to do. It's good code hinting. Microsoft supports this kind of stuff, right? And it's important for you guys to do this. Now, I know I need 2 variables. I need at least 2 literals anyway. I need a name, so we'll use my name. And we'll put an age in there, 25. How about that? Okay, if you can believe that. And then we're going to do some behavior, right? The person will talk, and you can see that I have access to doing that by using the method person.talks. We're going to use the dot accessor, right? That's what it is, to access the method, and it talks. The person talks. Cool. To test this, we're going to press Control F5. And then after my virtual machine kicks out, it's going to say Tom is talking. Yay! Wow. This is so interesting. Not. All right. It's not interesting at all. But the great thing is that we've done things a little differently. I'm going to add a couple of console.write lines, maybe with some, hey, question. Is it / or /? Is it this? Huh? If I try it again, does it give me a couple of them? Yeah, it does. It gives me a couple of them, right? And if I really want to, I could put in another one just to give me a little bit of padding, right? Oops. And there's definitely different ways of doing this thing. I'm being really lazy here, but it's okay because it's serving what I want you to see, right? And if I go back here, you can see that Tom is talking. Right, this is good. So I've got my first person. Hey, great. This is a great place to do 2 things, right? One, stop recording my YouTube video and take a 5-minute break, right? And the second thing I'm going to do, right, is I'm going to put it up to GitHub. But I'm going to do the GitHub piece first. So I'm going to go to Team Explorer, right? And I'm going to go to Home. And I'm going to go to Changes. Guys, and girls, you have to know how to do this. Remember, it's recorded, so you can see how it's done. So I'm here. I'm going to say something like this. Added person class, right? That's what I did. I added the person class, right? And I'm going to click Commit All. So what this does is it takes the changes and this commit. Is it on GitHub right now? No. This commit has to be pushed to GitHub. Remember that push part? We got to push it. So I'm going to click on Home. And I'm going to go to Sync. And I'm going to go to Push. And when I do that, bam, it's on GitHub. And if I want to check it, I can go back to my Mac side. And if I click on 8B, you can see now that I have 4 commits instead of 3 commits. And hey, look at this, added person class, right? There's my person class that I added. And if I click on there, all of these things are clickable, yeah? Look, every one of these commits. If I click onto this, right, and I look through, I can see that the pluses represent things that I've changed or added, right? If I remove something, it would be red, and there would be minuses here, okay? So you can see the changes that I made to my files. I added a whole new file, so 2 changed files. These are the two changes that I made. All right, so that's why GitHub is awesome. GitHub is awesome for 2 main reasons, well, 3 main reasons. And the 3 main reasons I like them is not just backup, but version control, and of course, sharing code with you, which is collaboration. All right, I think there's a great place to take a short break. Let's take 5, go to the washroom and all that kind of stuff, and come back, and then we'll continue with the second half of today's lesson.